Hey guys, today we're going to be going over the first derivative test and how to figure out when a function is increasing or decreasing, and also finding local minimums and local maximums. But first, you need to understand a couple things. First, if the derivative of a function is positive, that means the function itself is increasing. And if the derivative of the function is negative, that means the function is decreasing. So let's break that down. So, if the derivative of this function right here is negative, yeah, then the function will be decreasing. So, right here, this segment of the graph, obviously the slope of this line is negative, right? It's going down and to the right. So we know it's negative, and that means that the function is decreasing. So, if I start up here at some positive y value, I end down here at some negative y value. That's why when the slope is negative, our function is decreasing. Now, let's look at the opposite end of that. So let's say I have this segment right here. Okay, so obviously this is a positive derivative, positive slope. So I start here at this negative y value, but I end here at this positive y value. So the function is increasing, right? So that's what you need to understand. I drew this so you can kind of see it visually instead of just memorizing. So now, let's go to our first problem. X cubed minus 3x squared. First derivative test, obviously we want to find the derivative, so let's find the derivative of this function. X cubed minus 3x squared, this is just simple power rule. Boom, that's my derivative. Okay? So now, what you want to do now is you want to set this first derivative equal to 0 or undefined. Why? Well, let's say I draw a graph, okay? And my graph looks something like this. Alright, so the points where it hits 0 are here, here, and here. Do you guys see how it starts out negative? Once it hits 0, it goes positive. Once it hits 0 again, it goes negative. And once it hits 0 again, it goes positive, right? So every time it's hitting 0, it's changing signs, right? And signs are important because if the derivative is negative, then we know the function is decreasing, and vice versa with positive, right? So it's very important to us. Signs are very important in this lesson. Now, obviously there are some things that, like, right, the function could bounce off the graph. It could touch 0, right? It touches 0, but it bounces off. It doesn't go into negative. But we'll take care of that in a couple moments, okay? So, this is why we want to set it to 0, because we want to see where it changes sign. Now, you might be wondering, okay, why do I need to care about an undefined point, right? If it's the derivative is undefined, then it doesn't exist. Well, let's look at the graph of an absolute value function. That's a bad graph, but the derivative does not exist here, right? Because this is right here is a sharp turn. But we can see that this is a minimum. This is a minimum of the function, right? We can see that, obviously. So just because the derivative doesn't exist doesn't mean that there's no local minimum or maximum. So if you ignored undefined, when the derivative was undefined, you'd have missed this, right? You wouldn't have been able to say what the minimum was. Even though there is no derivative here, the derivative does not exist, there is a minimum value, okay? So that's why we use set it equal to undefined. So now let me just erase all this. So now, obviously, this function right here is never going to be undefined, okay? So we're just going to set it equal to 0. So 3x squared minus 6x equals 0. And let me put this in like a blue box so I know. This is the first derivative test. The first derivative is obviously very important. So now let's solve for this. It'd be 3x minus 2 equals 0. So x is 2, x equals 2 and x equals 0. Now, these points right here where the derivative hits 0 are called the critical points. Critical points. Alright, so now we do something very important called a sign chart. So, this is where we determine whether the derivative is negative or the derivative is positive, right? And like we said before, if the derivative is positive, then the function is increasing, and if the derivative is negative, then the function is decreasing. So there's a lot of different ways to draw this, but I draw it like this. So boom, boom. I split the domain into the critical points. So the domain of this function is just negative infinity to 0, right? I'm splitting it. And then 0 to 2, and then 2 to infinity. Now we're just going to put in any random number between negative infinity to 0 and plug it in to our first derivative. Let's say, guys, take some big negative number like negative, I don't know, 400 billion. That's between negative infinity and 0. So, let me just write this out for you guys for your first time. So, say some negative huge number, I don't know, squared minus 6 times some negative big huge number. Okay, so this is going to be positive, right? The negative gets canceled out by the square, and these two negatives cancel out because it's positive. So our first interval is going to be positive. All right, now let's move on to our second interval, 0 to 2. Obviously, we can just put in 1 for this, so it'd be 3 times 1 squared minus 6 times 1, and this would be 3 minus 6, which is negative. Okay, interesting. And now our last interval, 2 to infinity. You guys can probably guess, but let's say I put some big number here, squared minus 6 to... I don't even know if I'm writing the same amount of zeros, but whatever, doesn't matter. This is obviously positive, and this is positive. So, and this right here, this term is obviously much bigger because there's that squared sign, so this is going to be positive. Now, do you guys see? It's a plus minus plus. That means from... My teacher actually made us write like paragraphs for this, but I want you to make you guys do that. So negative infinity to 0, the function is increasing. The function is increasing. Okay, I won't write that out every single time. Function is increasing. 0 to 2, the function is decreasing. Decreasing, right? Because it's negative. Because the derivative is negative, sorry. And then 2 to infinity, it's increasing because the derivative is positive, like we showed on our sign chart. Now, this is what's important. You can memorize how this goes, or let me just draw like a quick little graph. Let me just erase this part right here. So if I draw a graph, right, and I say, okay, the derivative is positive, so positive, right, the derivative is positive here, and then it goes negative, and then it goes positive again. We can see that this point where it switched is like a local maximum. And this point down here where it switched again is a minimum, local minimum. Now, you don't have to draw that every single time. What I usually do is plus, I go up, and then minus, I go down. So obviously this is a max. And then a minus, you go down, and then positive, you go up. So this is a min, right? So that's what I do. But how you would write this is at x equals 0, there is a local max, and then at x equals 2, there is a local min. Alright, so that's how you do it. So this little thing I do over here, that's not like, I don't know, I wouldn't say professional, but that's kind of how I remember, right? So positive, you're going up, and then minus, down. You can obviously see that this right here is a maximum, and then vice versa over here. Negative, you're going down, and then positive, you can see that's a minimum. Alright, so let's move on to our next question. First step, take the derivative. Alright, so the derivative of this would be negative 1 over x squared. Let me box that because our first derivative is very important. If you guys don't know how I got that, well, this is just basically x to the negative 1, and then you do power rule. So this is our first derivative. Now remember what we said. We have to make this equal to 0 or undefined. Well, negative 1 over x squared. How can this ever be 0? Never, but it can be undefined if x is 0. So undefined when x is 0, right? X equals 0. So that's our only critical point right here. This x equals 0 is our only critical point. Alright, so now let's plug that in. into our, like, oh, let me label this sign chart. So x equals 0, we're going to put that into our domain. Split that. So 0 to infinity. Now, let's put in some big negative number, negative 100 billion. Negative 100 billion would become positive, but this negative's up here, so this would be negative. And then a big positive number, 100 billion, again, it would be negative. So what does that mean? It means that this function is decreasing everywhere where it's defined, right? So how I would write that is the function is decreasing everywhere. But, a big but, at x equals 0, it's undefined. So, the reason why I'm writing these out is because the AP exam, especially in FRQs, want you to kind of write it out, show your thought process. So, it's good practice. Now, where's our minimum and maximum? Well, so negative, I'm going down, and then negative, I'm going down again. Okay, well, this means I don't see any maximum or minimum. So what does that mean? It means there's no local max or maximum or minimum. Alright? So, I hope this is kind of getting a little bit easier. I have one more example for you. Alright, so this one is a little bit of a pain to take the derivative of. You're going to need to use product rule, but good practice, right? So you're going to get 1/3 x to the negative 2 over 3, x minus 4 plus x to the 1/3. Alright, and if I factor that down, I'm going to get 4/3 x to the negative 2 over 3, x minus 1. Alright, so let me circle this. This is our most important part. That is our derivative. If you're having a little bit of trouble finding derivatives, then I have 2 in-depth videos on derivatives on my channel. I recommend you guys watch those and then come back to this one just so you guys get the basics down. Alright, so now what's our next step? You have to set this equal to 0 or undefined. So first let's set it equal to 0. So 4/3. I'm going to get rid of this negative exponent. I don't really like it here, so I'm just going to put it in the denominator. X minus 1 equals 0. So when is this equal to 0? Well, when x is 1, obviously. And is it equal to 0 anywhere else? No, but we do have it equal to undefined. Why? Because look, if we can make the denominator of any fraction 0, then it's automatically able to be undefined. And when is this denominator 0? When x is 0. So, that means these two, 1 and 0, are our critical points. So now that we have our critical points, we can move on to using our sign chart right here. So now we're going to split negative infinity to 0, then 0 to 1, and then 1 to infinity. So those are our intervals. So, negative infinity to 0. Well, let's put a negative infinity into our first derivative. Alright, so let's plug in like negative 100 billion into this. If you plug whatever, some huge negative number, you're going to get a negative, right? Because this term, let me use a different color, pink. This term here will be negative. And then this right here, especially this part, x to the negative 2/3 is basically the cube root of x squared. If we have an x squared, obviously it's always going to be positive. So it's a negative times a positive, which is a negative. Now, let's plug in 0 to 1. You can plug in, I don't know, 1/2. Obviously, you're going to get 1/2 minus 1 is negative, so this is also going to be a negative. Now, let's plug in 100 billion, 1 to infinity. 100 billion minus 1, positive. And like we said, this is always going to be positive. A positive times positive is a positive. Alright, so now what does this mean? So from negative infinity to 1, right? Because they're both negative, so we can just say negative infinity to 1. The function is decreasing because the derivative is negative. And then from 1 to infinity, the function is increasing because the derivative is positive, like we said on our sign chart. Now, let's find our local minimum and maximums. So negative goes down, and then negative again goes down. Okay, so this means there's no minimum or maximum. So now let's do this one. Negative goes down, positive goes up. Okay, great. So now we have this minimum right here. So that means local minimum at x equal 1. X equals 1. All right. So this is our answer. This is not so hard, right? You're basically just finding the derivative and setting equals 0, and then you're done, right? By the way, uh, minimum and maximum are also called extrema, right? The extreme points of a function, but I mean, that's not so important. I just call them minimums and maximums. But anyway, if you guys have any questions, make sure to leave them in the comments. I hope you guys learned a lot. Next time we'll be going over like second derivative test, right? This is first and second derivative test, candidates test, and then figuring out concavity stuff like that. But if you guys have any questions or any other videos you guys want me to do, leave them in the comments below. Thank you guys so much for watching, and oops, and I'll see you guys next time.